Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve EJU Mathematics 2018 second session course 2 for number 6. By the way, this is the last number in this paper. If you want to watch the solution for the first 5 questions, you can check link on the description box below. Okay, in this question, we have two functions. The first one is y equals to x log ax, and then the second one is y equals to 2x minus 3, where a greater than 0 and log is the natural logarithm. Natural logarithm means this log can be called or can be considered as a ln. I think I will use ln instead of log. So our first equation is x ln ax. I will write down the first equation as x ln ax. And then let us find a. So our objective or our goal is we want to find a such that the graph of 1 is tangent to the graph of 2. So we can say that this straight line is the tangent to this curve. The equation of tangent to the graph of 1 at point t, t log at is a. For a, we have to choose the correct answer from among the choices 0 until 3 below. So we have to choose the correct expression for a. In this question, we want to find the equation of tangent. To find the equation of tangent, we need the gradient and we need the point where the tangent touches the graph. We already know the point. The point is t, t log at or t ln at. Yeah? Remember, log is the natural logarithm, which is ln. Since we already know the point or the coordinates, so I just need to find the gradient. If you remember, if we want to find the gradient of a tangent of a graph, we can use the first derivative. So I will find the first derivative of the graph. If I have y equals to x ln ax, then the first derivative is, this is the multiplication, so we have to use product rule. I will assume x as u and then ln ax as v. We have to use product rule. This is u and then this is v. If we want to find the derivative of u times v, then it is u prime times v plus u v prime. By following this formula, u prime is the derivative of x. Derivative of x is 1 times v is ln ax, plus u is x, times v prime. The derivative of ln ax is a over ax. You have to remember the concept or the formula how to find the derivative of ln ax. Basically, if we have y equals to ln f of x, then the derivative is f prime x over f of x. So the derivative of ln ax is derivative of the f of x, which is a, over f of x. If I simplify this expression, we can cancel out a here and x here. I got ln ax plus 1. Learn ax plus 1. This is the first derivative of y. So I can say that this is the gradient function of this graph. This is the gradient function of this graph. If we want to find the gradient, we have to substitute x. X is the point where we want to find the tangent. So I can substitute x as t, because this is the coordinate of or the point where we want to find the tangent line. So by substituting x as t, I got the gradient. Learn at plus 1. Once we know the gradient and we know the coordinates where we want to find the tangent, we can directly find the equation of tangent. Equation of tangent is y minus y1 is equals to mx minus x1. x1 and y1 is the coordinate and m is the gradient. So we will obtain y minus y1. y1 is t ln at. T ln at is equals to m ln at plus 1 x minus x1. Our x1 is t. By simplifying this expression or this equation, I think we will obtain a. Y minus t ln at is equals to this bracket times x. I will get ln at plus 1 times x minus this bracket times t minus t ln at minus t. At minus t. This bracket times negative t. We got negative t ln at minus t. And then if you simplify it, we can cancel out this expression or that term. So I get y is equals to ln at plus 1x minus t. This is the equation of tangent at point t, t log or t ln at. So the answer for A is this one, which is 0. Ln at plus 1 times x minus t. So A is 0. And then, hence, the graph of 1 is tangent to the graph of 2 when A equals to blah blah blah. And the coordinates of the tangent point are C, D. So we want to find this coordinate. We want to find this coordinate and we want to find the value of A. How to find the value of A and the coordinates? We can see from the second function. Remember that this second function is the tangent to the first function. As you can see, we already find the equation of tangent in terms of A and t. So, by comparing these two equations, y equals 2x minus 3, I can directly know that t is equals to 3 by using comparison. So t equals to 3, as you can see here, and then ln at plus 1 is equals to 2. Ln at plus 1 is equals to 2. If I move 1 to the right hand side, I will get ln AT equals to 1. Then AT is equals to e to the power of 1. You have to remember, yeah, if you want to get rid this ln, so there is e on the other side. So basically, if ln x equals to b, then x equals to e to the power of b. Since I already know the value of t, which is 3, we already find t. So 3 times a equals to e to the power of 1, of course it is e. Then a equals to e over 3. So a is equals to e over b. So I already know that b is equals to 3. And then the coordinates of the tangent point are c, d. What is the coordinate of the tangent point? The coordinate of the tangent point is t, t ln AT. We already obtained t, which is 3. So I already know that c is 3. And then for d is t ln AT. Just substitute t and a to this expression. So we will get d. So if I substitute t and a, I will get our t is 3 is t times ln a times t. So 3 ln e is 1. So I got d is equals to 3. D is equals to 3. For the next question, when a is equals to e over b, our b is 3. So for a equals to e over 3, function 1 is minimized at x equals to blah blah blah. So we want to find the value of x that can minimize function 1. Function 1 is x ln ax. This is my or our function 1. So I want to find the value of x that can be minimized x ln ax. The condition that must be satisfied for the function to be minimized is the first derivative must be equals to 0. We already found the first derivative. The first derivative is ln ax plus 1. So dy dx is equals to 0. Our dy dx is ln ax plus 1 is equals to 0. Since a is equals to e over 3, I got ln e over 3x plus 1 is equals to 0. By solving this equation, we will obtain x. How to solve this equation? Simply move 1 to the right hand side. I got ln e over 3x equals to negative 1. Same as earlier, if we want to get rid ln, so there is e on the other side. And then x is equals to, by cross multiplication it, or divide e over 3 to the right hand side, we will get 3e minus 1 over e. Or x is equals to 3e to the power of negative 2. So my e and f here is 3 and 2. E is 3 and f is 2. And then in this case, the minimum value is blah blah blah. If we want to find the minimum value, just substitute x to the function. So for x equals to 3e to the power of negative 2, we will get y is equals to x. Substitute x by 3e to the power of negative 2 ln A, don't forget A is E over 3 times x, 3e to the power of negative 2. So my minimum value is 3e negative 2, cancel out 3, and then e times e negative 2 is equals to ln e to the power of negative 1. Don't forget the properties of ln. If we have power here, we can move the power to the front. So I get y is equals to negative 1 times 3e negative 2 ln e. Ln e is equals to 1, yeah? So my minimum value is y is equals to negative 3e negative 2. So my g here is 3 and my h is 2. This is 3 and 2. Okay, I will continue to the next part. When a equals to e over b, once again, a is equals to e over b, my b is 3. Let us find the area. We want to find the area of the region bounded by the graph 1 and 2 and the x-axis. So in this question, we want to find area bounded by graph 1, graph 2 and the x-axis. For the following indefinite integral, we have blah blah blah. First of all, we have to find the indefinite integral of this. Why we should find the indefinite integral of this? Because if we want to find the area, we can use integration. So, first thing first, I will solve or I will find the indefinite integral of this. For I, choose the correct answer from among 0 until 3 below. Okay, how to find the integration of x ln ax dx? Once again, you have to remember, yeah, log ax is the same as ln ax because they already tells us that log is the natural logarithm, which is ln. Okay, to find the integration of x ln ax dx, we have to use integration by parts. Integration by parts. The formula of integration by parts is integration of u dv is equals to uv minus integration of v du. This is the formula that I use for integration by parts. So, if you want to use integration by parts, we have to know which one can be considered as u and which one is considered as dv. So we have to know first which one is u and which one is dv. Basically, u is something that we can be differentiated. So, u is the expression that we know the derivative. We know the derivative of x, we know the derivative of ln ax. So, for now, we still cannot decide which one is u because we know the derivative of both expressions. So let's move to dv first. dv is the expression that we know how to integrate. We know the integration of x, but we do not know the integration of ln. So I think my u is ln ax and then my dv is x dx. Because we know the derivative of both, but we only know the integration of x. We do not know how to integrate ln ax. Since we do not know how to integrate ln ax, so ln ax cannot be considered as dv. So this is u, and then this is dv. By using this expression, u times v, u is ln ax, times v. How to find v? V is the integration of dv. My dv is x dx. By integrate both sides, I will get v is equals to half x squared. So this is my v. U times v, half x squared, minus integration of v. We already know v is half x squared, times du. How to find du? Basically, du is the derivative of u. Since we already know that u is equals to ln ax, then if we differentiate it, we will get a over ax, which is 1 over x. Then du is equals to 1 over x dx. This is our du. So integration v is half x squared times du. This is our du. If we continue it, I will get half x squared ln ax. Cancel out 1x here. I got negative integration of half x dx. Then our final expression is half x squared ln ax minus, you can simply integrate this expression and it will becomes 1 over 4 or 1 over 2 times x squared over 2 plus. So my final answer is this. This is the indefinite integration of x ln ax. If we have to choose the correct answer, then the correct answer for letter I is 2, yeah? Half x squared ln ax minus 1 over 4 x squared. So I is 2. Okay? Last question. Hence, we obtain S is equals to blah blah blah. What is S? S is the area of the region bounded by the graph of 1, graph of 2, and the x-axis. To find S more clearly, I think we have to sketch the graph first. So I need to know which region that we want to find the area. Just draw a rough sketch. This is the y-axis and then this is the x-axis. First of all, I will draw curve or graph 2 first because 2 is easier. 2 is 2x minus 3, which is a straight line. Y equals to 2x minus 3. So the x-intercept, if you set y is equals to 0, then x equals to 3 over 2. Let's say this is 1, 2, 3, then 3 over 2 is something here. And then if you set x equals to 0 to find the y-intercept, then y is equals to negative 3. -1, -2. Assume this is -3. This is the graph of y equals to 2x minus 3, which is the graph of the second function. Remember that this line is the tangent of our first curve. Our first curve is x ln ax. X ln ax. This is our first function or first curve. This line is the tangent of this curve. The tangent point is 3,3. We already find it in the previous question. The coordinate of the tangent point is 3,3. So these two graphs will touch at 3,3. I think somewhere here. Just assume this is 3,3. So just assume this is 3. How to draw this graph? If I want to draw this graph, I think I need to find the x-intercept first. Remember, A is equals to E over 3, yeah? A is equals to E over 3. So if I find the x-intercept of this graph, y is equals to x ln E over 3x. If we want to find the x-intercept, then just set y as 0. 0 is equals to x ln E over 3x. So I have two possibility or 2 point of intersection with the x-axis. The first one is from here, which is x equals to 0. And then the second one is from this expression. Ln ex over 3 is equals to 0. If we want to get rid the ln, then there is e on the other side. E to the power of 0 is 1. Then ex over 3 is equals to 1. X equals to 3 over e. E is 2 point something, 2.7 blah blah blah. So I think 3 over e is somewhere, let's say here. 3 over 2.7 blah blah blah, I think something or somewhere here. So our first graph will passes through these two coordinates and touch the line at this point. Passes through these two coordinates and touch the line at this point. So I think the possibility or the curve of y equals to x ln ax should be something like this. To be honest, I do not know the correct graph of y equals to x ln ax, but I think it should be something like this. And then it will touch that line, something like this. So the area that we want to find is area of this region, which is bounded by the first graph, the second graph, and the x-axis. So this small tiny area here, this is S. Since we already know the area or the region, so we can see from this sketch how to find S. If I want to find S, I can use integration from 3 over e, this is 3 over e, yeah? Until 3, this is 3,3. Integration of the first curve from 3 over e until 3 you will get this whole thing, and then subtract it with this triangle. So if I want to find S, I can find it by using integration of x ln ax dx from 3 over e until 3. We will get all the region below the curve from 3 over e until 3, which is this whole thing, and then subtract it with the area of triangle. Then you will get the area of the shaded region here. For the integration, we already find the integration. The result of this integration is number 2. So S is equals to 1 over 2x squared ln ax minus 1 over 4x squared from 3 over e until 3 minus area of this triangle is half times base times height. Height is 3, and then the base is 3 minus 3 over 2. You will get the base here. Half times base times height. I will change A into E over 3 because our A is equals to E over 3. So I will change A becomes E over 3, EX over 3. Then substitute the upper boundary minus the lower boundary. If I substitute 3 to x, I will get 3 square, which is 9. 9 over 2 ln 3e over 3 minus 9 over 4. This is for the upper limit. Minus the lower limit, substitute 3 over e to this expression. We will get 1 over 2 times 3 over e square, which is e square over 9 over e square, ln ex, x is 3 over 3, e times 3 over e over 3 minus 1 over 4 times 9 over e square. 1 over 4 times 9 over e square. This is for the integration part. We got this, and then minus this one. Half times 3 over 2 times 3, which is 9 over 4. Okay, by solving this expression, we will get S. If I simplify it, I got, cancel out this, 9 over 2 times ln e is 1, then 9 over 2 minus 9 over 4 minus, cancel out e, and then cancel out 3, you got ln 1 here, ln 1 is equals to 0, so forget this expression because it becomes 0. And then the rest is 9 over 4 e square, negative 9 over 4 e square minus 9 over 4. 9 over 2 minus 9 over 4 is 9 over 4 plus 9 over 4 e square minus 9 over 4. Get rid this 9 over 4, so our final answer is 9 over 4 e negative 2. This is J, K, and L. So our J is 9, our K is 4, and then 2 for L. Okay, that's it for the last number of EJU Mathematics 2018, second session, course 2. Thank you so much for watching this video. I hope you can understand my explanation. See you on my next video. Bye-bye.